So we'll take a look at our next question. Example 3 says, what mass of sodium hydroxide NaOH is required for complete neutralization with 100 grams of HCl? Looking at the question, we have been given the equation for that reaction, and what we just need to do simply is, just as we've been doing before, calculate the molar masses of the individual elements making up the compounds there, sodium hydroxide and HCl. So let us take a look at what we have there. First, we need to bring out our equation and then check for balancing. So let us take it step by step. Sodium hydroxide plus HCl, that gives us sodium chloride plus H2O. Now we need to check if the equation is balanced at the left and at the right hand side. Sodium is 1 at the left, 1 at the right. Oxygen is 1 at the left, 1 at the right. Hydrogen is 2 at the left, 2 at the right. Chlorine is 1 left, 1 right. So the equation is balanced. So since the equation is balanced, we don't need any balancing. So we just proceed to solving the question. Now let's get to understand the question. It says, what mass of sodium hydroxide? So you can see sodium hydroxide is needed in the question. It is an important species. What mass of sodium hydroxide is required for complete neutralization of 100 grams of HCl? So we are most interested in sodium hydroxide and HCl. And from the equation, where is sodium hydroxide and where is HCl? Both of them are found at the reactant side, that is at the left-hand side. So please take note of that. Sometimes your calculation will involve somebody at the left-hand side and another species at the right-hand side. But in this case, as you can see, both species that are required are found at the left-hand side. So it is possible. Now, we have, they said, 100 grams of sodium hydroxide as against HCl. So what mass of sodium hydroxide do we need? Now let us take a look at what we can do. First, we calculate the molar masses of those species we need. And for sodium hydroxide, we have 23. Sodium is 23 plus oxygen is 16 plus hydrogen is 1. So this is for sodium hydroxide. And against HCl, hydrogen is 1 plus, please, this is not minus. Let us look at this. It is wanted to know that that is not minus. It's just, let us, so that we don't get it confused. Sodium is 23 plus 1 plus 16. And it is coming up against HCl. So we have HCl, hydrogen is 1, plus chlorine is 35.5. 35.5. So we proceed. Now, to sum this up, 23 plus 1 plus 16, that gives us 40. So this is 40 grams. So 40 grams as against HCl. HCl is 1 plus 35.5. That gives us 36.5. 36.5. So what it simply implies is that 40 grams of sodium hydroxide requires 36.5 grams of HCl. But the question says, what mass of sodium hydroxide is required for 100 grams of HCl. So what we simply need to do is, from the equation, 40 grams of sodium hydroxide, we need 36.5 grams of HCl. So the question said, what mass of sodium hydroxide are we going to need for 100 grams of HCl? So it means that to find the mass of sodium hydroxide needed for 100 grams of HCl, we don't know. So that's going to be X. So 40 grams of sodium hydroxide, we need 36.5 grams of HCl. Now, if HCl becomes 100 grams, how many grams of sodium hydroxide are we going to need? We don't know. So we place X. And the next is cross multiply. So we cross multiply. And by the time we do that, we're going to have 36.5 times X is equal to 40 times 100. And we have 36.5x is equal to 4,000. So to find our x, we have dividing both sides by 36.5. Our x, this can take care of that. So 36.5 can take care of 36.5. We therefore have x is equal to 4,000 divided 36.5. And when we do that, we have 109.6 grams. So it simply means that 109.6 grams, 109, let's have this. So it simply means that 109.6 grams of sodium hydroxide will be required, is required for 100 grams of HCl. So that is what it simply means, and we have just done that. So this is how to solve questions under stoichiometry. Dear students, we understand that stoichiometry in chemistry seems to be a hard rock to swallow. But I bet you that once you pay maximum attention, follow this calculation step by step of each way, you will get to understand it at your fingertips. It is so easy. Stoichiometry is the simplest, if I'm to say, topic in chemistry. So easy and so flexible. Now let us take a look at the next example. We have our next example. The question says, calculate the number of moles, now not mass, calculate the number of moles of calcium chloride, CaCl2, that can be obtained from 25 grams of limestone. Limestone is CaCO3 in the presence of excess HCl. Now, looking at that question, we have been given their relative atomic masses. So you can see that we are most interested in two species, and the equation for the reaction has been given to us. The equation for the reaction is being provided. So how do we go about carrying out that calculation? First, we need to balance the equation. And to balance the equation, that is if it is not balanced, but from what we have, the equation is balanced for us. It is already balanced. But if it is not balanced, then it means we will have to balance it ourselves. The equation is already balanced. Calcium carbonate plus 2 moles of HCl, giving us calcium chloride plus water plus CO2. So from what we have, from all indication, the equation is balanced. So what we just need to do is take the next step. What is the next step? finding the two species you are most interested in. And those species are, look at it, calculate the number of moles of calcium chloride required that can be obtained, calcium chloride that can be obtained from 25 grams of limestone. So, and limestone is calcium carbonate, that is CaCO3. So let us take a look at our equation first. We have calcium carbonate plus HCl. That gives us calcium chloride plus water plus CO2 giving off as a gas, and this is 2 moles. So once again, we have the equation given and it is already balanced. So we are interested in calcium chloride and limestone. So we are asked once again to calculate the number of moles of calcium chloride that we can get. This time not mass, but number of moles we can get when calcium carbonate, that is limestone, is made to react with HCl, 25 grams of limestone. So what we need to do is calculate the molar masses of this species we are interested in. So we are interested in calcium carbonate and calcium chloride. So let us proceed. All other species are less important for now. So we are told that 25 grams, let's just put it somewhere. We are told that 25 grams of limestone was provided. And from that 25 grams of limestone, the question simply is, we are going to calculate the number of moles of calcium chloride we can get from 25 grams of limestone when it is made to react with HCl. So what do? First, we calculate the molar masses of calcium carbonate and calcium chloride. So to do that, calcium in calcium carbonate is 40 plus carbon is 12 plus oxygen is 16, but there are 3 atoms there, so it's going to be 16 times 3. Then over here we have calcium is 40 plus chlorine is 35.5, but there are 2 atoms there, so it's going to be 35.5 times 2. Now to sum this up, we have 40 plus 12, 16 times 3, that gives us 48. And here we have 40 plus 35.5 times 2, that gives us 71. So to sum this up, 40 plus 12 plus 48, 40 plus 12 is 52, 52 plus 48, that should give us 100. So this gives us 100. So it means 100 grams of calcium carbonate, we produce 40 plus 71 is 111 grams. So it means that 100 grams of calcium carbonate, we produce 111 grams of calcium chloride. So if that is the case, from the equation, the balanced equation, now what we need to ask ourselves is, if 100 grams of calcium carbonate will give 111 grams of calcium chloride, then 25 grams of calcium carbonate will give X grams of calcium chloride. That is, 25 grams of calcium carbonate, how many grams of calcium chloride will it give us? We don't know, so we have to put X. So what do? Cross multiply. Once we cross multiply, we have 100 times X is equal to 25 times 111. So this is 100X is equal to 25 times 11 gives us 25 times 111. That will give us 2775. That gives us 2775. So we have 2775. So the next we need to do is divide both sides by 100. to get our x. Dividing both sides by 100, so we have 100 can take care of 100, therefore x will be equal to 2775 divide 100 will be 27.75 grams. So it simply means that 25 grams of calcium carbonate will produce 27.75 grams of calcium chloride. But dear students, this is not what is being asked. We are not asked to calculate the mass of calcium chloride that will be produced from 25 grams of limestone. The question says we should calculate the number of moles of calcium chloride we can get from 25 grams of limestone. So what do? We have only succeeded in calculating the mass of calcium chloride that will be produced from 25 grams of limestone, not the number of moles. So what do? It is to recall that number of moles is N. Number of moles is represented with the symbol letter N, small letter n. And small letter n has different relationships, as we saw when we started the topic, when we started calculations in stoichiometry. We have n is equal to CV over 1000. We have n is equal to V over molar volume. We have number of moles is equal to mass over molar mass. We have number of moles is also equal to number of particles over Avogadro's number. These are the relationships we saw when we are trying to talk about number of moles having close relationship with other parameters. So looking at the following equations, can you tell us, what do you think? Figure out which of these formulae is most ideal to getting what we are asked to get, the number of moles of calcium chloride. Which are we going to use? To determine what we desire, we have the mass, we have calculated the mass of calcium chloride successfully, and this is it. And they asked us to calculate the number of moles of calcium chloride. So that tells us that we will make use of this formula. The third formula is most ideal. So that is what we are going to make use of. We're going to make use of the third formula, and to do that, why do we choose to make use of the third formula? N is equal to mass over molar mass. N is equal to mass over molar mass. N is what we are asked to find, the number of moles of calcium chloride. Mass of calcium chloride, we have just calculated it to be 27.75 grams. And the molar mass of calcium chloride, we have also done that, is 111 grams. So that makes the job easier. So N is equal to 27.75 divide 111. And what will that give us? It gives us our answer, which is 0.25 moles. So this is our answer. It's as simple as that. 0.25 moles will be our answer. So this is how to calculate any kind of question whatsoever given to you under stoichiometry. So as you can see, to get our number of moles, we have it as 0.25 moles of calcium chloride. So we must be very careful looking at the question, so we are not carried away. When you are asked to calculate number of moles, you calculate number of moles.